Boom! What up, Zane here? We're doing another Leetcode problem, this time number 6, and it's zigzag conversion. So what we're doing here is we're taking this made-up zigzag pattern. So you can see this string is PayPal is hiring, so it goes PayPal is hiring. And then we imagine if we take each of those rows like this and combine them together, so PAHNAPL instead of PAYPAL. And so we combine each of these rows together to make one long string. So you can see PAHN, PAHN, APL, blah, 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 APL. And so we're just combining all that together like that. Why would anyone ever want to do this? I don't know. But we're not here to question that. We're just here to make it happen. Okay, so I've started us out with some test cases and the starter code that is on the website. And so let's get to it. So first, as always, we're going to create a somewhat inefficient solution, and then we'll move on to our try-hard efficient solution. All right, so let's just go ahead and create a mutable result, which will just be an empty string at first. And then we'll go ahead and return that just to get rid of the error messages. And then what we're going to want to do is cycle through each character. So let's say for C, we'll call the character C in s.chars. And then we'll keep track of which row we're on, and we'll have a bunch of rows of strings. So we'll say, actually, we'll have the result will be, instead of a string, it will actually be a vector of strings. And so we'll just create new strings, and it will be as long as the number of rows we have. So we'll keep track of each row separately in its own string, and then we'll combine those rows together. So we'll at the end we will concatenate those together. Okay, so that should reduce all the errors. So this needs to be as use size. So let's just go ahead and say num rows equals num rows as use size, just to get rid of that error, because we'll be comparing them with indexes in the future as well. So now we just need to keep track of whether we're going down or up. So as we go down, we'll be increasing the current row, and we'll keep track of the current row too. So, and then once we get to the end, we'll reverse the direction and start going up. So how we'll do that is we'll say let mut cur row, so we'll start at row 0, and then we'll also have a variable called down, which will be true at first. So we'll start out going down. If you look at the PayPal, you can see we go down first and then we go up. And then at the end of the row, so once we get to here, we'll reverse the direction. And then here we'll reverse the direction again. And so we'll do that once we get to the end index or the beginning index, we'll reverse the direction just over and over again. All right, so easier said than done. Let's get to it. So then we'll start out on the right row. So we'll push the character that we're on to this string, and you can just push a char type to a string, which is awesome. Makes it really clean. So we'll say result at the current row, and we'll push that current character. And then we will need to go up or down. So we'll say if we're going down, we'll add 1 to the current row. If we're going up, then we'll need to subtract 1. So we'll just say cur row equals, or we could say plus equals if down. So Rust doesn't have a ternary operator, so we just have to do this basically. So if we're going to go down, if we're going down, we actually need to add 1 because it's actually increasing the index that we're on as we go down. So down is actually more positive than when we go up. And then if we're not going down, then the current row will be subtracted 1. So plus equals negative 1. And this isn't going to work though, because cur row is a U size. So we can just, what we can do is just say current row plus 1 or current row minus 1. So that will get rid of that error, and that won't give us, so I don't know why, but it was thinking that there could potentially be a negative number, but not if we do it this way, so it's kind of dumb. I don't know if that's a bug or what, but anyway, so then we need to check if we need to reverse the direction of the going up or down. And so we can do that. We'll just need to measure if we're on if the current row is 0 or if we're at the end. So if we're at the beginning of the row up here or at the end down here. So any of these we would need to reverse the direction. Any of these we would need to reverse the direction. So how we'll do that, we'll say down equal to, and then in parentheses we're going to type cur row is less than or greater than 0, and the current row is less than num rows minus 1. So what this does is it says down equal to whether or not down is at the end or not. So if we're in between these two, this would return true if we're on one of the middle rows. So if we're between this row and this row, this is going to return true because cur row is greater than 0. So this is row 0, and it's less than num rows minus 1. So the total number of rows is 3. 3 minus 1 is 2. The index of this row is 2. So as long as it's less than 2. And so when we're on 1, that would return true. But when we get to the end of the row, this is going to return false. And so down is true. So that's going to set down to false now because down does not equal that. And so then when we're going up, so down would be false. So we would say false is equal to the current row, basically to the that we're inside of that we're in between the two ends of the rows. So this is going to return false. So this is going to return true. And that is going to be true is not equal to false, so down will stay false until we get back to the first number. And so now that we're at the first number, the current row this is going to be false. And so we'll say if false is equal to false, and then that will set down to true. And then it's just an endless cycle. This will cycle us back and forth. I did not come up with that, but I think that's pretty genius. So this should return us the correct result. So let's try that out. So we're getting an out of bounds error. The problem is we're not handling when there is only one row. So we're adding 1 to the row because we're going down, and then that row doesn't exist. So we need to simply say if num rows.length is less than 2, then we'll just go ahead and return that string because if there's only one row, then basically it can just be flat. So here we're actually pushing to the top vector. We actually need to be pushing to the current row of the top vector. Okay, so this should just be characters. So I don't know how that got in there. All right, so now we're passing all tests, and we can go ahead and run that. Okay, so we'll submit that and see what our inefficient solution yields. So 4 milliseconds and 2.1 megabytes of RAM, that's not bad. Okay, so now how can we make this even better? So let's take a look at the question again. And we could, instead of cycling through, allocating all those arrays and then pushing each character to the array based on the number of row we're on, we could just mathematically calculate where each character should go. So we could say, since this is number 0, the letter 0, this will go to 1. and then we'll find the next one so we can see how many characters in this cycle we have. So we have 1, 2, 3, 4. 4 characters, and then we start a new one. So we could divide these basically into 4 sections. So this is one section of 4, this is another section of 4, this is another one, and this is a partial section of 4. And so how do we calculate that? So we would take the number of rows, 1, 2, 3, and then multiply that by 2, and then subtract 2. And the reason we multiply it by 2 is because you can see we have 3 right here. That's the number of rows. If we multiply that by 2, but we need to take the end caps away. So we take this away because there's only one of these. But there could be infinitely many middle characters. Okay, so what does that look like? So let's do our try-hard solution now. We'll erase all our old code, and then we're gonna cycle through each of the rows. So we'll say for 0 to the total number of rows, and we'll call this row. We'll say the row we're on, and we'll cycle through the rows, and then we'll also cycle through the cycle. So we need to get the length of the cycle, which I already said how we calculate that length. So we set cycle length equal to the number of rows times 2, and then subtract 2 from that for the end caps. Okay, and so then we'll say for cycle in 0 to cycle length. And actually, this isn't going to work, but we'll worry about that in a second. Okay, and then we will collect the result. So we won't need a bunch of arrays now. We'll just have a result. So we'll say the result equals just a new string. So string new. So this will just be an empty string. And then we can cycle through both of these and get our answer. So let's say instead of actually counting each of the cycles, we can actually set our cycle equal to 0. So we'll say let cycle equal 0, and then we'll count our cycles just by adding the cycle length to our cycle at the end of each loop. So we'll say cycle length plus equals cycle length, and then we'll make sure that cycle plus the row, so the cycle we're on, and that will be the total cycle. So for this one, we'll have 1, 2, 3, 4. So the next cycle would be start out at 4. 0, 1, 2, 3, 4. And so we can keep on going through the cycles like that. So this would be, if the number of rows is 3, 3 times 2 is 6, 6 minus 2 is 4. So then we start out at 4. So you can see that we're getting to the beginning of each cycle every single time. So this would give us A, H, N first if we just did this cycle, if we just push that character. So let's go ahead and do that actually. Let's just push the character, and we'll just ignore every other row. So we'll go from 0 to 0. And so we'll push the character that we're on from the character. So in order to do that, we're actually going to need to convert this to characters, so a vector of characters, so that we can get each character by the index. So we would say let sv, so that's just a vector of characters, string vector, equals s dot chars dot collect, and we'll need to collect that, and we'll have to explicitly declare the type. We can ignore this because it'll infer that it's a character array from the chars. And then, so let's go ahead and return our result so that we can get those squigglies away. And then we'll push the cycle plus the row. So we'll push the character in the string vector at the cycle plus the row. And we'll need to do that while cycle plus row is less than the total length of the string, because once we're past that, then obviously there would be no more characters, and we'd have an out of bounds error. So we'll set this while it's less than the length of the string. And so that should give us PAHN for the first one. So let's find this one. So just so we can visualize it better, we'll use that test first. Okay, and we will print this out. And so let's just get rid of all of our other tests for now. And we will print out the result just for funsies. And I need and this is semicolon up here, and so that should work. It's actually inferring that cycle is a U size because we're comparing it here. So we can fix that by, we can just set we'll let a variable n be equal to the length of the string, and we'll set that as I32, so that should get rid of that error. But this also needs to be a U size because you have to index array by U size, just because they don't want you to accidentally get a negative number, because there is no negative reference to a vector. So we need to actually use our n value here, and so that should make this go away. And let's see, we actually need to make result mutable, and then this should work. So we should be printing out PAHN there. So let's say result, but it looks like we're not putting out anything. So looks like our result is not being pushed. So from 0 to 0, let's say from 0 to 1, because it's up to and not including. Okay, so you can see we're getting our first row there. But we also need to get, once we get beyond the first row, we also need to get this one and this one. So for the second row, we'll need to do that. So we'll go back, revert our code to this number of rows. Then we'll need to do something similar to what we did before. We'll say if we're between those two end caps. So the end cap is going to have just one. So we're only going to have one here and one there. But we also need to plan for, there's going to be two when we're on the middle row per cycle. So there's two in the middle, and there's only one at the end caps. So okay, so now this should also get the letter if we're at the end, if we're at the bottom as well as the top, because when we're at the bottom, see, we're adding that cycle plus the row. So the cycle is just the start, so that's right here, and the row is the row we're on. So once we get to the second row, so that was just the 0th row. So once we get to the first row, to row number 1, which is the second row, that would be 0 plus 1. So row would be 1 there. So 0 plus 1, that would give us that A. And then so we also need to say 0 plus the total size of this cycle minus 1 to get that P. And so we'll add that. So we'll say if we're not on one of those end caps, so if row is not equal to 0, so that's the first, and that's the first row, and row is not equal to the total number of rows minus 1, and then we also need to make sure that the ending is not going to be beyond the total length of the cycle. So we could have, like here we have just a G, but if we try to get whatever's on the other side, so we're going to add the total cycle length and then subtract 1, that would be an out of bounds index error. So we have to make sure that we're still, so we'll basically have to make sure that the cycle plus the row minus 2 cycle actually, so we're actually going to be subtracting the row, because the row we're on, because we're going backwards, so we're going backwards to the P here, and then so cycle plus the cycle length minus the row, so plus the cycle length minus the row is less than n, so we don't want to have an out of bounds error. Okay, and so if that is true, then we will push the result, which will be this stuff right here that we just did. So result dot push, so we're not doing the current row. Oops. Equals, let's just copy that stuff. All right, what's the error now? What now? So it found an I13. Oh, we're actually needing to get the vector, the character at that index. So that should work, but we need to cast this to a usize, because that's the only way we can index an array. So we'll try that. So we're getting, okay, that's not too bad. We're only getting one error. So actually, we're changing the cycle length before we've actually done that cycle. So that should work. Okay, and we need to uncomment out all our test cases. And let's see. It sure is taking a long time to run, isn't it? Alright, so there's obviously something wrong there. Okay, so we forgot to add if it's a string. If it's just one row, then we need to just return this string. So this is just going to continuously cycle. So we'll say if num rows is less than 2, then we'll return s. Okay, so all right, and there we go. So let's submit that to Leetcode and see what we got. All right, let's see if this works. Okay, so 4 milliseconds, 2 megabytes. 2 megabytes is really good. That's the best one I've had. I had 1.9, but 4 milliseconds. I was able to get one that was down to 0 milliseconds, but it took basically like 3 times the amount of code as this. So we're probably just going to stick with this. If we did it again, it would probably eventually say 0 megabytes or 0 milliseconds, 1.9 megabytes. Okay, so that's way less memory. All right, so, and there's just probably some optimizations that the compiler does in Rust that make that slightly faster, my other way slightly faster. So we'll go to, let's look at other people's solutions. So, full disclosure, I basically stole this guy's for the non-efficient one, and it was a lot better than mine. I actually do every problem myself without looking at any answers, but his code was just a little cleaner than mine. So that's why that guy's code probably looks eerily similar to mine. Okay, so this is probably my favorite one. If I were doing production code, this is probably what I would do because it's so readable. So essentially, well, I don't know if it's readable, but he's essentially creating, chaining the numbers, so 0 through the number of rows, and then he's getting the in-betweens and putting those in reverse so that he basically creates the row that each character should go to, and it cycles between them. So 0, 1, 2, 3, 2, 3, 1. So that's what this code is doing by putting this in a chain and reversing it. Chain just adds to the vector, and reverse just reverses the range that he gave it originally. And so then he's mapping each of those to the characters. And so this essentially just keeps cycling through. This would go infinitely many, except that we give it a certain finite number of characters that it collects from and maps to, and then it ends. And so then it collects those together, and then he sorts by the row that it's on. So he maps it. Basically, this zip creates a tuple of the row and the character, and then he takes that tuple and sorts it by the row that he's on. So remember, he gave each one a row, and so he's going to sort each of those characters by the row. So he'll have all the characters of each row consecutive one after another. And so then he just takes each of those and maps the character to it and collects it, and that creates a string. So that I think is a really clever solution, and this guy shows a real mastery of the Rust language and create such clean code. I mean, our code is good, but it's just not as clean. And so he's taking advantage of the Rust built-in iterate functions. I think this guy's code is the best. It's way better than ours, but ours is more efficient. So that is the zigzag conversion. So won't you join me next in our reverse integer problem? And this is a really easy one, so this shouldn't take very much time at all.